Today's lesson is on Pythagorean's theorem. Pythagorean's theorem, first of all, is a theorem, and a theorem is a proven fact. Okay, now Pythagorean's theorem, I don't like to think of it as a squared plus b squared equals c squared because sometimes people don't emphasize that c must be the hypotenuse for that to be true. Okay, so I prefer leg squared plus leg squared equals hypotenuse squared. The legs touch at the right angle, and they can be different lengths. They don't have to be the same length. And the hypotenuse is opposite. The right angle points at it. So let's practice using Pythagorean's theorem. Also, there are several proofs of Pythagorean's theorem when we actually can look at if this side were the length, if it were a square, the area of that square plus the area of that square would equal the area of that squared. And we could use a little geometry and figure all that out. We won't prove that today. We're actually going to practice applying the theorem. So, for example 1, we want to find x, and x is here, which is on the hypotenuse. You always want to recognize which sides are the legs and which sides are the hypotenuse. So, leg squared plus leg squared equals the hypotenuse squared. Make sure that the hypotenuse is on the side of the equal sign by itself. Now we're going to solve for x. So we get 64 plus 4 equals x squared. Combining those like terms. And now taking the square root of both sides, we get absolute value of x. And here, make sure you simplify this radical. Don't forget to simplify your radicals. So 4 times 17, which gives me 2 radical 17. And notice how I'm staying on the side of the equal sign. I'm not crossing over at all. Here, absolute value of x, when you remove the bars, you make the other side plus or minus. However, the minus sign, the negative result would be considered extraneous because lengths can only be positive. So x equals 2 radical 17. Now I'm looking for my units. These sides are measured in inches, so the hypotenuse would also be in inches. But if you were trying to measure that, that wouldn't mean very much. We say that this is an exact value answer. That's exact value. However, when you take different tests, they might ask for the nearest 10th or nearest 100th or something. Let's round that to the nearest 10th. So you can just punch that in the calculator and you would get that that's approximately, and we use the wavy equal sign whenever you round off, it's approximately 8.2. And again, we must include the units. Okay, so let's do another example just to make sure. But before we move on, recall that the hypotenuse must be the longest side. So let's even write that down. The hypotenuse is the longest side. And so I always like to double check my math. That's 8.2 inches. And so that is longer than this leg over here and this one. So you always want to double check that it is the longest. Okay, let's go on to example 2. And here I'm more specific. I say find the exact value of x and then round to the nearest 10th. So we're going to do the same thing that we did in the last example. What are you going to do first? Make sure you know which sides are the legs. This is a leg. This is a leg. Across, that's the hypotenuse, and it's the longest side. So here I'm going to say leg squared plus leg squared equals the hypotenuse squared. And notice I'm putting parentheses. Notice I'm putting parentheses around these. For x squared, we don't really need it, but here you must be careful. So that's 2 squared, and then we square that radical. So here, 2 squared, and then radical 2 squared. You see that? Equals distribute 8 squared, and that's radical 3 squared. So I want to make sure you see what's going on. So we have x squared plus 4. The square and the square root cancel, so that's just a 2. Here we have 64 for the 8 squared, and now the square and the square root cancel, so that's times 3. So x squared plus 8 equals, what is that? 180 plus 12, 192. And now we're going to subtract 8 from both sides. And we get x squared equals 184. We're going to take the square root, absolute value, plus minus disregard. And we get x equals, that's 4 times 46. So exact value answer would be 2 radical 46 centimeters. But if we did nearest 10th, punch that into the calculator, we get 13.6 centimeters. And when you're measuring, sometimes you want the decimals, but sometimes not. Notice this answer, this problem started with radicals. So I think it would be best to deliver the answer as radicals. Okay, so you have to look at different things. Let's move on. The triangle sum theorem says that the 3 angles of a triangle add up to 180 degrees. Okay, so if you had a triangle, angle A plus B plus C, or I should say the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. That's what the theorem says. Okay, you add those 3 angles. Okay, so all those degrees add to 180. So now, looking at this triangle, let's see what x must equal. Now this one's unique because that's a right angle. So we know that's 90 plus x plus 25 equals 180. And this would be the equation. Combine like terms, subtract 115. And we would see that x equals 65 degrees. That would be the measure of this angle. However, there's a theorem that says if you're in a right triangle, that the other 2 angles add up to 90 degrees. So we could have said x plus 25 equals 90. And that would have been less work. And we still would have gotten that x is 65 degrees. Let's do a word problem. 2 hikers leave a cabin at the same time? Okay. After 1 hour, Susie, walking south, had gone 2.8 miles. I usually like to underline or circle important information. And I'll talk about steps a little bit for word problems. Dolores, walking west, okay, that might be important, had covered 3.1 miles. Okay. At that moment, which I guess is 1 hour later, what is the shortest distance between them? Okay. So for word problems, you always want to read and make sure you understand what's going on. Then try to draw and visualize the problem. Next, you want to try to write an equation, solve, check, and always answer in a sentence. I always have students say, do I have to put it in a sentence, Ms. Adams? Well, the sentence shows context and understanding. So sometimes if you just give a number, oh, the answer is 5. 5 what? 5 where? What does this 5 even pertain to? So you want to give it context. Now, the south and the west are probably important. So let's say this is the cabin. Okay, we have a little cabin. Okay, oh, my roof is crooked. So in the cabin, it says Dolores, no, who first? Susie walks south for an hour and had gone 2.8 miles. And I'm just going to make it from the corner of the cabin. Okay. Now, first of all, do we know our directions? If this is north, let's make a compass rose. Everybody's pretty good with north and south, but then people get a little confused on the east and west. If north is at the top, then east is always to the right. And if you think about a map of the United States, you know California is on the west coast and you know the east coast, okay? So Dolores went west 3.1. And I think it's important to acknowledge that the compass rose is at a 90-degree angle. So we have 4 90-degree angles here. So we have a right triangle, and we want to know how far apart Dolores and Susie are. So the shortest route is definitely a straight line. I'm going to call that X. So 2.8 squared plus 3.1 squared equals 8 squared. Nope, X squared. Good job, teacher. X squared. So we're going to add those values together and we get 17.45 equals X squared. We're going to take the square root of both sides and I'm going to flip it around. And in this case, a decimal would be just fine. These are decimals, 3.1, 2.8. So I'm going to give 1 decimal place, just like those gave 1 decimal place. We call that significant digits. So now, is the hypotenuse the longest side? 4.2 is longer. It makes sense that they would be getting further apart the longer they walk. Now let's answer in a sentence. What were we asking? What is the shortest distance between them? So I might say Susie and Dolores are 4.2 miles apart. Okay, I think that's an appropriate sentence. Okay. Now, hopefully you've heard of Pythagorean triples. These are numbers that often you'll see often. And to be exact, there are 3 positive integers, positive, so no negative numbers, where a squared plus b squared equals c squared. So if I ask you, are these numbers a Pythagorean triple? What I'm really asking you is, could these numbers be the side of a right triangle? Which side would be the hypotenuse? The longest side. Okay? And 8 and 15. And so I would say, is 8 squared plus 15 squared equal to 17 squared? And notice there's a question in my voice. Is it equal? Answering the question. So that'd be 64 plus 225. Does that equal 289? Hopefully you know your perfect squares. And that is 289. So I could definitely say, yes, these are a Pythagorean triple. Now, I'm giving you a few popular Pythagorean triples, but it's definitely worth me saying that there are infinitely many Pythagorean triples. 3, 4, 5 is probably the most famous, but please know, if you doubled all of those and got 6, 8, 10, that's also. So all of these you could do multiples. I could multiply by 30. I could multiply by 100. So 300, 400, 500 would be another triple. So there are indeed infinitely many. You'll see these numbers when you get to working with right triangles. They'll come up. You can double them, triple them, multiply by any number. You could even multiply all of them by radical 2, and they would still be Pythagorean triples. So it's kind of magical. Yay. You could multiply them all by pi or whatever. And like I said, there are infinitely many Pythagorean triples.